Alright, the third topic in the Captain's License course is chart navigation. Chart navigation it's one of my favorite topics. I like them all, but chart navigation is the one it's very hands-on, has a little bit of math involved, and you can really see what's going on with chart navigation. So here we go. You switch colors to blue, and we'll talk about the topics that are involved in chart navigation. There is compass course, so we can figure out the compass course. If we left in one spot and we ended up in another spot, we can figure out what course we traveled. On the chart, there is estimated time of arrival. You'll see it abbreviated this way: ETA, estimated time of arrival. Your Garmin's in your car and things like this will have an ETA. It'll say arrival time and give you that arrival time, and it'll change based on traffic in that case. Speed made good. Speed made good. Speed made good. And people say, what do you mean made good? How do you make speed good? All this speed made good, this is just the average speed. Average speed. It's just different terminology for saying average speed. Speed made good, average speed. So what's the average speed you traveled between point A and point B? And range and deviation. Range and deviation. Deviation. And with these problems, we actually calculate our deviation based on a compass bearing and a true bearing. We can calculate the deviation, and you might ask, what is deviation? Deviation is the compass error that your vessel, your ship, your boat puts on your compass. Let's say you have a tool. You're getting strange compass readings, and you have a big bag of tools too close to your compass. That bag of tools affects your compass, and that effect is called deviation. We have 3-point fix. 3-point fixes. This is a triangulation. Based on 3 known bearings, we can figure out our latitude and longitude from the chart. We have a known current. Known current. And in these problems we say, okay, with a certain set, the direction of the current, and drift, the speed of the current, what course should we steer to accommodate for that set and drift? And we have unknown current. Unknown current. And in these problems, we actually figure out the current that affected us while we were on a certain course, because we end up somewhere where we didn't think we'd end up. So we take where we thought we'd end up and where we actually ended up, and we can figure out the set, which is the direction of the current, and drift, which is the speed of the current, from that difference. Now let's switch to red here and kind of go through one of these speed made good problems, because this one has the components, a lot of the components that all chart navigation is made up of, which is distance, speed, and time. Right? This is what we'll be working with: distance, speed, and time. And time here is always in hours when we use these. We'll use a little, if making formulas isn't your thing, we have this little cheat sheet. We call it D Street math. So distance equals speed times time. Speed is distance over time. Time is distance over speed. You can get all of them from this. So let's look at this speed made good for a second. If we start here and we end here, and say, so we start at 10:30, and then we end here, and we end at 12, which is noon, right? This goes into PM. This is AM. So we have a certain distance, right? We have a certain distance, and because we're on this nautical chart, we can take dividers, which we'll be using for chart navigation, and we can measure this distance on the latitude scale. See how this is a dark dash, light dash, dark dash? Each one of these dashes is 1 nautical mile. So let's say 1, 2, 3, 4, 5 nautical miles here. See, so you can get a sense on how we can start measuring distances. 5 nautical miles. Now let's assume this distance is that 5 nautical miles. You can see that it probably isn't, but for demonstration's sake, let's say it's 5 nautical miles. And our time, right? Because we're looking for a speed. This is, again, speed made good. What's the average speed is the question. So speed, what is the speed? So to get a speed, we need distance. See, you can see here, we're looking for speed, which is a distance over a time. So speed is distance over time, and our distance, 5 nautical miles, divided by our time. Well, we got there at noon and we left at 10:30. So if we do this, if we say 12 minus 10:30, we get 1.5 hours. Now this, if you take the course, you'll see why we're only in hours here. It's because speed is in nautical miles an hour. So this is some time stuff here. So 1.5 hours. So if we do this, we get the average speed. Let me get my phone and do this. So we have 5 nautical miles divided by 1.5 hours, and it's equal to 3.3 repeating. So 3.3, let's just say 3.3 nautical miles per hour, which is also equal, nautical miles per hour is equal to knots. You hear people talk about knots. So 3.3 knots. Okay, so this is a good example of what chart navigation consists of. And there's one more video that describes what makes up the courses, and that is Deck General and Safety. So we will see you in the Deck General video.